Hello everyone, welcome to Blue Dragon Universe. This is the Excel Advanced course, and this is the part 2 of counting and summing techniques chapter. Right, so there are several things that we have seen till now, but today we are going to learn about the different ways we can count the number or count a text within a given range of text. Right, so here you can see in column A we are calling this data, and you can see the name is data, and the data have several words, and along with that we have one thing that we need to search among those several words, right? So here we are going to use county, if we are going to use the array function like we have learned before, and then this is how we are going to understand how the how to calculate the number of words, right? Alpha. So here you can see, like, just by visual check you can determine that there is one alpha here, one alpha here. So it should be two, right? And it is that is how it is, but there is one alpha here as well, right? And that would, if it is not case sensitive, right? So then that should be three, right? So that is how it should be, right? So there is one alpha here, one alpha here, and one alpha here, right? So that is how we should kind of like, we should give for a case sensitive search, we should get only case sensitive means similar, like for a similar search alpha and alpha, in this case we should get only two occurrence, right? And for something which is kind of not case sensitive, then we should get three occurrence. So let us see if that works and how we can do that. So first is count if data. We have taken data, and within the data we have taken the text, right? So obviously you can see that here it will find the alpha, and here it will find the, will it find the alpha here? No, it will not find the alpha, it will find the alpha here, right? So let us check if that hypothesis is correct or not. Otherwise we'll have to correct ourselves, right? So let us, and how we can check, we use check by evaluate, right? So here we go, so this is alpha and this is the range, and immediately it does not show much, right? So when we use the count if, right, so it is either skipping this one or is skipping this one, right? So the best way to judge this is if I remove this, right? So you can see this alpha is it is not case sensitive, right? So that is why it is identifying this alpha and this alpha. But the moment you see something like alpha text, it is not identifying that. How can it identify that, right? So we already know we have to insert a wildcard, right? If we insert a wildcard, then it will identify that. So if I just do this and put the asterisk, right? Let me write the asterisk, and then I'm going to concatenate this, right? And then again I'm going to concatenate this with the asterisk. So that means it will be changed to a wildcard, right? So if it is a wildcard, then I think it should determine the alpha beta as well. Let us check this if this works. So right now it is working, right? So alpha here, alpha with the asterisk, that is why you are getting the alpha here and then beta, right? So that is how you can get the alpha. So here earlier it was only recognizing this and this, so it means count if is not case sensitive, right? But if you want to check that as well, because it is accompanied by another word, that will not work, and for that we have to use that kind of method, right? Now entire cell, right? So there is another method that you can use, which is the exact method. We have seen this method earlier, and it shows that you know it shows that this is how the sum of this shows that exact of data and text. So if it is the exact of data and text, that means whenever you see an exact match, right? Exact is in that manner, so it will just identify this cell. And you have already seen the application of if, like that. If exact of data and text, if this is true, then you get one and sum that, right? So in this case you are getting only one, right? So I think exact case is also understood. Now let us look into something, maybe like this one, where we have this is the case that we have already considered, right? So maybe let us remove that asterisk one, right? So we have already considered the asterisk one, so that is why I just wanted to keep two separate, right? So that is how it is, right? And this is the case where this is also good. There is nothing that we can say about that, and we have already kind of learned this, right? We're using the asterisk. Now the part of the cell, now there is another way you can identify this, and this is using the substitute function. This is where I kind of closed the video yesterday saying that we are going to use substitute. So we already know how to, like, if we already seen this application, if we want to determine the number of words or number of spaces, this is the application that we have used earlier, right? So len of data, it will give you the length of, and this is an array function, right? So it will give the length of every word. And so that is why when you think in from in part of array, like how you think in array is like you think of every word, right? So length of this and length of this and length of this and length of substitute data text and this. So then if you do this calculation, so wherever you get this text, you are going to substitute that with nothing, right? So this alpha will be substituted with nothing. Similarly, this one will be substituted, only beta will be present, right? And this one will also be substituted nothing. Remaining things, there will be no substitution. So basically length of this and length of this will be 0 if there is no alpha, but if there is alpha, then it will be it will be positive, right? So that is why I have written greater than 0. So if length of this and length of this, right, will be greater than 0, then only you add 1. So once again, let us use the evaluate formula to understand this better, right? So the moment I use evaluate and click on this, so it is taking all the all the entries in the data. Now it is getting the length of all the entries in the data. Right now, if you click on this, it is again getting the length of the the substitute, and it is substituting the text alpha here. So we already have the length. Now we are substituting the text. So if here if you do that, so here you can see this alpha is just becoming nothing, right? Here also this alpha beta is becoming just beta, right? And in this case, this alpha is not getting substituted because once again it is case sensitive, right? And we know how to convert this into a non-case sensitive thing by using upper or lower, right? You can do that, but we are going to see that later, right? So the moment we do that, so this alpha is not getting substituted, right? You can see that because it is not similar to the alpha that is present here, right? So now once we do that, so for couple of things we see that it is 0, right? So here it is 0 and here it is 5. 5 minus 0 would be greater than 0. And also there will be another one. Here it is 10 and here it is 5. Otherwise the length of word will remain the same. Only if there is alpha, then the length of the word will decrease because we're getting it replaced with nothing, right? So that is where here we see 10, here we see 10, right? And finally yeah, we get false and true, and true is for only two cases. So if you sum this, we get 2, right? And in this case, how we are going to change this, similar process, right? But if you see this here, we have converted this the entire data into upper, and so that is why the case sensitivity is removed, right? And finally this one, which is there is another method, that is you get the length of the data, right? And you get the length of the data here, right? And you replace that, whatever that thing is, you divide it by the length of the text, right? So once again, and I don't I don't prefer this formula. I'll probably use this or this. Probably this is a better formula because it is not case sensitive, right? But if you want to understand that, so let us go in. So, we already know that length, right? How it is operating, and also how it is kind of substituting, right? And how the length we are getting. So we know that the remaining things would be 0, right? So 30. So here we can see the sum, right? And we know that the only places where we'll see some difference, right? So here the length would be total length of everything, whatever data is present here, and here the same concept, but it's slightly in a different way, right? And then here sum and length of the data without the alpha, right? Without the alpha. And if doing that, we'll get the difference, and that difference, if you divide by the length of this, you will get the right, the number of words, right? It's just mathematics. Whatever is present, if you deduct it from whatever that is not present, the difference would be the number of times, right, equal to the length of that what is present or not present, right? So that is how it is. So 38 minus 20 divided by, that is 10 divided by 5, right? And that is the difference. So basically, if I do this, we get 2. So the same concept has been used, and we are determining alpha, right? So I think probably the best approach would be used to probably use countif and use the asterisk that will give you the another count. Probably everyone is going to use that approach. However, anything that you can do with countif, you can do that with array function. And as I mentioned, array function would be the last chapter. Array function is so powerful, and there are so many things that you can do, but you have to visualize that in the form of array function, right? So it is not easy to visualize the that you are taking the length, then the length of every array would be, every item would be given, then we also take the length of something and that length would be given. So that is how it is, right? So that's it. Let me check if I have missed anything. Nope, I think I have covered everything. Right. Count function can also be, like count of something can also be done through pivot table, right? Pivot table, like you can create a frequency distribution and something like that. But I'm just thinking that because we also have a chapter on pivot table, so maybe we can cover that in that chapter, right? So instead of doing that, let us move into something we call frequency distribution. There is a function called frequency. We rarely use that function, but we can, because once again it is like an array function, right? So you can use that function to determine the frequency of a data, and then we can close this video by seeing some summing techniques, right? So summing techniques would be slightly more easier. Yeah, but let us complete the frequency and then we can go to the summing techniques, right? Okay. So here we have a data, and that data we are calling this data, obviously, right? And we have classified this into something called beans, right? Beans mean we like the upper limit and lower limit. If you have seen any statistical distribution, so it is like between 50 to 100, there are 12 counts. There between 100 to 150, there are 11 counts in that way, right? So here we have just denoted the lower limit of that range, right? How we have done that, that we need to understand, right? We know that row would give you the corresponding row number, and rows will give you the number of rows in a data, right? You already have seen that. So here we have used row and not plural rows. Minimum data, that will give you the minimum of this data, which in this case is one, this one, right? So minimum, and then row multiplied with this one, max data minus mean data plus one, this will give you the range of the data, like the total number of elements that is present here, right? Whatever element is present here, in this case, that is this is 125, so that would be given here. So here you can check this, right? Max minus min plus 1, select this and press F9, right? So here, sorry, it will give you the, the total, the maximum amount, right? The maximum value that is present. In this case, it is 500. So that is the total number. I mean, if I show you this, so max of data is 500, right? And the minimum of data here is 1, right? So that when you divide by 10, right, that when you divide by 10 will give you the, like, it's range. By range, I don't, I mean, actually what I tried to mean was the difference between the maximum value and the lower value plus 1, right? So that will give you the this count, which is 50. Like, because I know this is the way this has to be calculated, I created the formula in that manner, right? So 500 minus 1, that will give you 499, right? And if I divide it by 10, it will be 49.9. I don't want that, so I just added the 1, right? And also, if you follow the AP series or GP series, this is what will last minus first plus 1, that will give you the total number of elements, right? So I was talking from that angle initially, but here in this case I know that I want 15, right? 50. So what I did is, so this will give me the row number. So in this case it will be row number minus 1. So it is in the second row, so I have added mine, subtracted minus 1, so that I get 1 less. So 1 into this 50, and then, so if I just evaluate this formula, right? So once you write one formula, you can drag it down, right? So minimum is 1 and row is 2 minus 1, which is 1. This 1 is being multiplied with what we call the, the range, right? And divided by 10, because we want 10, kind of levels, 10 bins, right? So that is where you are saying that 500 minus 1, that is 499 plus 1, that is 500, right? Divided by 10. Now, obviously, you do not write the formula at one go. Nobody understand this, right? So you always break the formula into multiple pieces and then you write the formula. right? That is how I have done that as well. And then 500, then I know that this should be 50, right? So there, that is why I deducted -1 from there, right? So all this are like I wanted 50 here. How can I get 50 and make it dynamic as well? So that is the thought process that I had, and I created this, right? And I know max data, main data, all of this has been, kind of discussed when I wanted something that will vary with the row, right? I needed a row. I can also place an array here, right? Array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like that, and make it an array formula. So once you have, like I mentioned the example, Sachin Tendulkar has multiple shot for the same ball. So once you know the plethora of techniques, you can use, whatever technique you choose there to kind of create this, right? So second one, the only difference would be that this row would be 2, right? And third one, the only difference would be row would be 3, and in that way, right? So that is the only case. So you can maybe, select this row segment, and if I do a F9, it will show you 3, right? So you can understand how this calculation is happening, right? And then I am using something which is a function call, which is an array function, which is frequency, right? So what frequency requires is you give the data, and you have to classify data in this manner, like the lower limit or the bins, right? So frequency gets the data which is given here, then G2 to G11, which is this one, and this is an array function, right? So you have to select all the cells and write the frequency function, right? And the moment you do that, it will automatically give you the count. You do not have to use countif, or other than that you can use countif. We have that example as well a bit late, in this tab, but you can use this frequency function or frequency formula as well to get this, right? And once you get this, determining the percentage, I think is not that difficult, right? Count of data and frequency of the corresponding, and then you are getting the result. You can also take the sum and divide it by this, right? Same thing. It is like this 12 divided by sum of, right, this entire thing, and I'll freeze that so that it does not change, right? So same thing, right? So it is here I'm using the array formula because frequency is an array formula, right? Very few people uses frequency because it is an array formula. So that is why, you I do use that. So that is why it is, kind of difficult to understand, and very few people have understanding of array formulas. But for our case, the Excel Advanced Mastery series, here you have to understand array, right? Then only you can give 9 out of 10 in when you someone asks you in an interview. So this is how it works, right? So when you write the frequency formula, in this case, right, you have to kind of select the cell and then write equal to, right? And then you write the frequency, right? So you immediately it shows, like if you see this, calculate how the values occur within a range of values, and then return a vertical array, right, of numbers of one more element than the beans array, right? So you know how this works. Now if I select this data, right, so data is, you can select this, or you can freeze that, you can write data as well. So I'm going to write data because I'm going to replicate the same formula, and I don't want to, because data is automatically freezed, right? Now I want to select the beans array, right? Here I'm going to freeze this, right? So the moment I close this, if I just press Control Enter, if I just press Enter, then it will, it will not work properly because it is, maybe let me just do that to show you. So here it will only give you value for only one data, but it is an array of data, right? So if you copy this here, right, it is going to give you the same value, right? Which is not working. So how you can change this? Once again, select all the cells, press F2, right? And now press Control Shift Enter. So the moment you do that, you'll get the value for all the data. So always remember, frequency is an array function. It returns an array, right? So that is why it is an array function. It returns an array. And this is I think this is a much easier way. In even in CP2, CP2 is an actual paper. So in CP2 also we get problems like this where you have to categorize data into multiple things, and this is an easy way to do that. If you can determine the beans, and determining the beans is very easy, like how many range or how many classes you want to determine, and using that you can usually get the data. But yeah, not everyone is familiar with the array formula. So that is how it is. The other way you can do this, I have a similar example. So I've classified this into min and max, and how you can do that: count if grade less than equal to the grades, right? So if it is less than equal to D2, that is, if it is less than equal to means it has to lie above this, right? So this means the grade number has to be more than 90 and number has to be less than equal to 100, right? So then you also get the frequency, right? In that way it works in this way as well. And where you have, so whenever there is a grade like from 90 to 100, it is A, and 80 to 89, then it is B, right? And 51 to 79 is C. You can also use the count ifs, right? Count ifs or count if to get the frequency. Also you can use the frequency function. It's up to you, right? So it is up to you. If you can categorize the data into beans, right, then you can use either of those, right? For some people who are not familiar with array function, frequency would be difficult to understand, but countif would be much easier to understand, right? And I hope we are getting this. We have already seen formulas like this. I have also explained how you can use countif, right? Instead of count ifs, how can you count if? So in count if, it will be less than equal to this minus count if less than equal to this. At that point of time, it is not be greater than equal to, it will be less than equal to this. You deduct those and you will get the frequency, right? So I think you should be kind of familiar with this one, right? So let me check if there is anything else. So that will conclude our count section. I think everything that I wanted to cover, how you can play with count tips, how you can play with array formulas. The array formula was very, very kind of important, right? So I think I have covered that. Now I think we'll move to the probably the aggregate function, which is a kind of sum function, but it is much more powerful, right? So we'll move to the sum functions in the next section. You already know how to determine the sum. I think that is not an issue. But a couple of things maybe, and we also need to know about cumulative sum. So suppose you want to sum this and sum this and sum this, or maybe you want to sum this and you want to sum this 3, right? You do not want to sum this 750. So this is how you can do that, right? Sum, and it requires array or number. So you put b2 to b3, then put comma, remove the 750, and then this one, right? So it will basically it is summing without this. So you can verify this by selecting this, and you can see 3450, and we have also got 3450, right? Now this is the cumulative sum. Once again, cumulative sum is very important from CP2 perspective as well, actual paper perspective, or something that you need to know. So here I have written b2 and I have freeze the 2, but remaining things I have not fixed. Like, so in the b2 to b2, initially it is b2 to b2, so it will only take this cell, but then it will keep on increasing as we drag it down. So b2 to b3, and then b3 to b4. So how you write that is like this. You select this b2 and then you put the colon, right? So the immediate moment you put the colon, it will it will automatically give b2. Now if I do this, then it will, if I drag this down, then it will be b3 to b3 and b4 to b4. It will basically, it will not amount to much. It is just like equating this to b2. So here we are going to put the dollar, right? The moment I do that, then I can drag this down in that way, right? So now the 2 is constant, 2 is fixed, and remaining things are changing, right? So this is how you get the cumulative sum, right? Here you can see the sum is kind of here there is no data and the same number is repeated. You can counter that using an if function. So if this is empty, right, if this is empty, so this is not equal to anything, then do not then put empty there, right? So you are using the same function, same formula, is just you have made it slightly more better formatted, right? So in that way, and you can see the result. Now suppose there is an error, right? Suppose there is some number 78 divided by 0, right? Suppose there is an error. Now this will not work, right? This will not work. And suppose then there is another number here which is 3400, right? So here, because there is one error, right, this would not work, right? Here also you can see the sum is not proper, right? So there, as I mentioned in the last section, there is a function called aggregate, which is a very powerful function. So you calculate aggregate, right? And first you need to select what you want to do. There are so many things you can do with aggregate. See this, all the descriptive statistics are covered here. So here I am going to take the sum, right? And then you put the comma. So here it will ask you what sort of things that you are going to do. So here I am going to choose. So see, there are so many options. You can ignore nested subtotal, you can ignore hidden rows, right? So many things, but in this case I want to ignore error, so I am selecting 6, right? And next I am getting the array, right? So what are the arrays that you want to choose? So here I'm going to choose this entire array, right? So if I choose this and I'm going to freeze this, right? So if I do this, so here I'm going to get the result, which is 9300, which is same as this one, because if I also put 3400 here, I think it will see, this is 9300. So what happened here is sometime you have error in the data, right? Some data would be erroneous, and here aggregate is a very powerful function, and there are so many things you can do with this. You can play with this aggregate function. I this is a function that we are probably going to enter in later part of our course as well, but this works like subtotal, right? Subtotal basically, if you are filtering some range, and the filter, you want to take only the sum of the filter. Otherwise, if you take a normal sum, it will give the sum of the entire range, right? But if you only want to take the sum of that filter, then subtotal will work. A kind of like, for example, suppose I add a filter once again by select control shift and the right arrow, then control shift L. Now suppose I want to select only Jan, Feb and March, right? So if I only want to select the first quarter, you see that this, right now aggregated function is showing the entire thing, right? Because we have not made the correction. Now suppose if I take the sum, right? Suppose if I take the sum, and if I take this 3, then that will be fine. But suppose how long this sum is, it is still B13, right? So if I write B13, let me change this, right? B4 to B13, because I want something that for which I will not need to change the range. I want the formula to be dynamic, right? So if I do this, right, so it will not, first of all, it will not give me error, and then it will be the problem with this is there is the I mean it is, even if there was numbers, right, it will still be giving me the entire number. So for example, if I just remove this and remove this dip 0, right, so you'll see that it is giving me the sum of the entire thing. So suppose this control shift L, and then I'm going to select Jan, Feb and March, right? So it is showing me 9300, which is not what I want, and I don't want to change the, suppose I want to check the value for say April, August and December, right? So I cannot select every time. I cannot go and change the sum function here, right? So for that, there is one function which is subtotal, and we can also use aggregate. But let us first understand subtotal, right? So subtotal, right? Subtotal, and here also there are plethora of things that you can do like aggregate. So I'm going to select sum, right? And then comma, and then the number reference, right? So number reference would be same, which will be b. So once again I am going to put the colon, so it will be b2 to b13. I'm going to change this b2 to b13, right? That is the range. Let me freeze this, right, and put a comma. So then remaining things are optional, I don't need that, right? So this will sort of ensure that whenever I change the filter, I do not have to change the range, it will automatically kind of get updated, right? So here you can see it is 1100. Now suppose I want to check for June, March, and July, right? So now it will see automatically this sum is not changing, but subtotal it is changing, right? It is only checking this value 2450. You can verify this value here as well. Same thing can be done here in aggregate, right? So suppose we go here and, oh sorry, this is sum. This is not going to change. Now in 6, in place of 6, see there are so many things: ignore hidden rows, nested subtotal, aggregate function. So you might have a subtotal within that as well, right? So here I am going to maybe 3 is a better option, right? So instead of 1, maybe you can use 3, right? And sorry, I think 3 is not selected probably. Yeah, let me put 3 here. 3 is this one, right? And let us enter. So you can see it is also working in the similar way. But aggregate is much more powerful than subtotal because aggregate can also skip. You might have a aggregate function within this as well, which is also aggregating. So aggregate will skip that aggregate. Otherwise, there will be double counting, right? So if you have an aggregate function within, suppose June is aggregating the result from Jan to May. So and then from July you have new data, right? June is just like the collection of the data from Jan to May. In that case you need to eliminate the aggregate function, so then subtotal will not work, but then aggregate function will work because it will eliminate that as well based on this whatever option you are choosing. So this is a very powerful function which very few people know because people just do normal sum, right? But subtotal and aggregate, these are database functions, right? And we'll understand what is database when we come to table and list. But I mean, these are database function and this is how it works with filter, right? So yeah, that's it. Let us see if there is anything I wanted to cover. Yeah, I think I've covered most of the things for this, the aggregate and the subtotal, right? So I can skip this and move to the next section. Okay, here we have some data, and here we are going to learn about sum if and also some array function. So suppose you want to kind of check the data where the difference is zero, less than zero, negative data only, right? That means that it is past due data in this case. So how can you do that? Difference, sum if difference, which is less than zero, right? You have already seen such application in COUNTIF. You can also do that through array formula. So you already know this. If difference is less than zero, then some difference, right? So if difference is less than zero, then only those cell would be highlighted, like thinking like array, right? And then you are going to sum the difference, right? So only this cell would be highlighted, right? And remaining would not be considered, and then this cell would be kind of sum, right? So for all this cell, it will be true, 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 true. Remaining would be false. So only this, the value for this true cells would be summed, right? I think I'm not showing by using evaluate function because you have already seen that using countif for countifs. Now total amount past due. So this means sum if less than zero. So wherever the difference is less than zero, right? For that we want to count the sum. Now once again, you can come here. This is the range, right? This is the criteria for the range, and this is the sum range, right? So sum range in this case would be the amount, right? And you can then do the same thing using, so if sum if difference less than zero, then sum on the amount, right? So I think this should be easy to understand. Now only when Oregon is considered, so you can use office, right? And the criteria would be Oregon. Office is basically this one, right? You can see this is named office, and Oregon, you can see how we are using the named ranges, right? So it is very precise to use. It's very easy to understand for someone who is taking a look at your Excel file, right? Even for CP2, I'll suggest this method, right? Everyone, and we already know how to like, just for a kind of table of data, how can we easily create a name range, right? So we have already covered that, so it is very easy to do that, right? So if you can do it for total for Oregon, you can do it not when it is not for Oregon, right? So it is just is for not for Oregon, you are going to just use the not equal to operator. This is the not equal to operator, right? So I think this is easy. Now then total amount with due date beyond May, right? So due date is given here, right? And which is beyond May, right? So that means here we are going to use this greater than equal to and date, which is 2005 1, right? So this is the date function. You'll get more clarity when you cover the date and time chapter. But I think this is the way you convert a normal couple of normal entries into a date. This means the year, this is the month, this is the day, right? So whatever is greater than this day is kind of covered here, right? So I think you get the picture. And then this is total amount, total past Oregon. So this is the difference, which is office is Oregon. So here we are using two criteria, and here we are using sum ifs. The difference between sum if and sum ifs is, in sum if the sum range would be in this side, would be the last entry, but in sum ifs the sum range would be in the first entry, right? So here you are taken amount, then these are the criteria. Difference is less than zero, office is Oregon, right? And you can do the same thing using the arrays. We have already seen the application of arrays. Difference less than zero, office equal to Oregon. These are and, right, multiplied, so this means and then it is multiplied with the amount, right? Then total amount, I think, yeah, that's it. Total past months due. So if office equal to Oregon, these are the this is an array formula. So total past due amounts or amounts for Oregon array formula. So if office equal to Oregon, plus means or, right? It is or. Here it is or, it is written, so that is why plus, right? And difference is less than zero. So if that is the case, so basically office is equal to Oregon and difference is less than zero, right? So then 1, so then you are going to get 1, or else you are going to get 0, and then we multiply that with amount. So whenever this two condition is true, you are going to get 1, and otherwise it will be nothing will be there, right? So it will be 0. So whenever this condition is true, the amount would be multiplied and you are going to get this result, right? So I think you get the picture, right? And if you understand how that set theory works, you can do anything in array formula for with regard to counting, right? With regard to counting or summing, and you can use a sum ifs, which is kind of similar to the count ifs, right? Or sum if, which is kind of similar to the count if, right? So I think that's how it is. Let me check if there is anything else that I want to cover. Otherwise, I think this is done, right? Let me check whatever I've written down. So that's it. I think I've covered everything. I've just checked my notes as well. And yes, I hope you are enjoying this series. This will be the last video that will be uploaded in YouTube. And for the remaining part of the series, you have to purchase the course, which I hope that will be uploaded on 31st of March 2025. And I hope that you understand what is the level of this course, how advanced we are going, and how can you make a real impact and actually finally say that you deserve 9 out of 10 in Excel. 1 is still something which that 1 from 9 to 10, that is still reserved for someone who is creating the Excel file, Excel application, right? But if you know all of this, then definitely you can give yourself 9 out of 10. So that's it. See you in future video.